Hello, first thing I'm going to show you about compound interest is how to use the GDC to calculate compound interest very easily. Just to review, we'll look back at the problem that we did in the investigation. When you do a compound interest problem, the calculator does a lot of the work for you. So, do you need to write out the formula with the substitutions done? Yes, you do. Why? Because in case you do something wrong with the calculator, if you write out the equation with the substitutions, you'll be able to get partial credit. Okay? So what is the formula you're going to use? It's just the same one we used in the exploration. So it's future value equals present value times 1 plus the interest rate divided by 100k k to the n. So this is exactly what we used in the investigation. So, and I'm going to show you how to use the calculator to do this. The explanation's right here, but maybe me talking through it is a little bit easier. So let's take the problem with the future value equals 10,000 reais times 1 plus 24% interest divided by 100. And first we'll do the case where we do compounded semi-annually or 2 times a year, so that means k is 2. So k is 2, and what was n? N was 1 in the investigation, so it's 2 times 1. Okay, so in the end we have present value equals 10,000. And like we'll say that's, yeah, present value is 10,000. And then we'll put R equals 24%, right? K equals 2, and N equals 1. And then if you write all this out in the problem, then even if you mess up on the calculator, you will still get a lot of the points. How do you do a compound interest problem on the calculator? First, you press this purple button called Apps, and it should give you 2 or more applications. You're going to choose the finance application. In the finance application, there's one called TVM Solver. That's the one you want. Press Enter. Then it gives you many variables which look quite familiar, which are N, PV. Some of them are not familiar. So N we know is 1. I is actually the same thing as R. So we're going to put 24. PV, remember, is 10,000. PMT, we don't use in this class. FV is the future value. We don't know it yet. Payments per year, we also don't use in this class. Okay, compounding period, or compounding per year, that would be the same as K. So in the first case, we're going to use K equals 2, so we'll put 2. Now what do? We don't know FV, and we want to know FV. So we go put the cursor back up on FV, and then we're going to go alpha, which is the green button, and then we're going to hit enter for solve, green solve. And it tells us 12,554. This number should look familiar because 12,554 is the amount that you would pay back from a loan if in 1 year you had 24% compounded semi-annually. Okay, so K was 2, present value was 10,000, interest rate was 24. Remember, it was 12,544. Now, why is it that the present value was a positive 10,000 and the future value was negative 12,544? We'll look at it from the point of what comes into your wallet is positive and what goes out of your wallet is negative. So remember, it was a loan. So the $10,000 comes into your wallet, 10,000 plus 10,000 as present value. Future value, how much are you going to have to pay the bank back for your loan? You're going to have to pay them a little bit more than the 10,000 you got, and we'll consider it a negative number because it's leaving your wallet. Okay, so 12,544 is a negative because that's what you're going to pay back to the bank. So that's why the amount for the present value is always going to be the opposite sign from the future value. Now let's try the case where the compounding period K, instead of 2, was something like 12, which was 1 year. Let's see what we get for that. Then we'll go back up again to future value. We don't need to blank it out. We just put the cursor on top, and then we do alpha enter again. And then now it gives you a value of 12,682. That's for compounded monthly. Now remember, we also did compounded daily. Do 365 for C divided by Y. And then once again, we'll do alpha enter. And what do we get this time? 12,711. These numbers should look familiar, right? Then we'll go to the case where, okay, what if I want to do compounding instantaneously? Well, I can't do compounding instantaneously, but I could put a really big number like 1,000,000. What happens then? Look at, it was 12,711. How much is it going to go up? A lot of you guys predicted that it would go up just a little tiny bit more, so let's see what happens. Oops, I did it wrong. I was supposed to go up here and do future value. Alpha, enter. Do you see it went up just like one real? Okay, so even though I made it go from 365 to 1,000,000, it only went up like 1 real. Do you see? And then, like, with this tool, it's very easy to do, even more bigger numbers, and it's just like effortless because you just change that number, then you go up to future value, you hit alpha solve again to get the new value. You see, like, it hardly changed. Okay, so we can see that we're approaching some kind of threshold number, but we never reached the threshold. So that's the way compounded instantaneously works. You're approaching a number, even though you're increasing the K to a very big number, you see the future value hardly changes. Okay, so now let's do a few problem set problems. So we're on the first problem set. I'm only asking you to do 2 problems today because you're just learning how to use a calculator. The important thing is, hey, let's write down the formula and what the variables are. Shunsuke invests 3,000 yen at 6.5% interest compounded annually for 15 years. Calculate the amount of money that Shunsuke has after 15 years. Okay, so the interest rate, R, or we could say I, is 6.5, right? And we don't put 6.5 divided by 100 because remember in the formula already has 100 there to divide the 6.5 and make it into a decimal. So you just put 6.5. The present value is how much left his wallet. Negative 3,000 because it left his wallet. 15 years. 15 years is n equals 15, right? Because n is the number of years. In the investigation it was 1. Here it's going to be 15. Is there anything else we know? Well, it says compounded annually, so that would be k equals what? K equals 1, right? Calculate the amount of money that Shunsuke has after 15 years. So let's write down the formula. Future value equals present value times 1 plus R 100k k to the n. So let's see what we know. We know present value is 3,000. We know that R is 6.5. K is 1. And N is 15. So now we're just going to put some of these numbers into the calculator. N is going to be 15. The interest, which is the same thing as R, is going to be 6.5. Present value, we're going to put negative 3,000 because this money is leaving Shunsuke's wallet. So we'll put negative 3,000 because it's leaving. Payment we don't use. Future value, we don't know what it is because it's asking us what the future value is. How much of money does he have after 10 years? 15 years. And then the number of compounding is going to be 1. So now we're just going to check, okay, what is the value of future value? We're going to do alpha solve. And it'll tell us that after 15 years, the future value is going to be 77715.52. Okay, and then the second part of the equation is how long would it take for his money to double? Okay, so instead of figuring out what FV is when n is 15, we're kind of doing the opposite. We're going to figure out what n is going to be if we know future value. Future value is going to be double of 3,000, so it's going to be 6,000 times 3,000, 1 plus 6.5, 100 times 1. Okay, and one thing that might be confusing is the way the calculator works and the way this formula works. As you can see from this formula, there's no reason why negative 3,000 is going to give you a future value that's positive. It's not, okay? The way this formula works is positive numbers give you positive numbers. The way the calculator works, it's always thinking in directions. So it's like, and the reason why the calculator is complicated like this is because the calculator is capable of doing complicated things, like you could like do payments on the bank loan, and you know it has to know which way the money is going. When you use this formula here, all we're thinking about is like a fixed amount of money growing. So there's no direction here. That's why there's no positive and negative. Okay, so whenever we do the formula, there's no signs. But when you use the calculator, then you're going to have a negative. When it leaves your wallet, you're going to have a positive when it comes back to your wallet. So like for example here, if you're going to write this equation, you can see that it's going to be a positive 3,000 is going to grow to a positive 7,715. And a positive 3,000 is going to grow to a positive 6,000. And then you say, well, where's the negative? Well, the negative only happens on the calculator because the calculator tool is quite complex. Okay, so in this case, that the future value is 6,000, and I'm going to put positive 6,000 because the 6,000 coming back to you. What is going to be n? Do you think it's going to be less or more than 15? Well, in 15 years, remember, he got 7,715. So to get 6,000, that's less. So he should not take 15 years. He should take something less. Let's see what it is. Alpha solve with the cursor on 15. We get 11. Okay, so n is going to be 11 in that case. Okay, now the last problem, because I'm only asking you to do 2 problems for this problem set. Andrew, Billy, and Colin, and we'll call them A, B, and C for short, each have 2,000 euros to invest. Andrew invests his 2,000 euros, and so the present value is 2,000, in a bank that offers 4.5 interest. So the R is 4.5. Billy invests his money, his 2,000 euros, in a bank that offers an interest rate of 4.4, compounded half yearly. Semi-annually is half yearly. How many times per year is that? It's 2. By the way, the first one was compounded annually, so that would be k equals 1. What about Colin? Colin also has 2,000 euros. It's in a bank that has an interest rate of 4.3, compounded quarterly. So quarterly would be how many times a year? 4. Calculate how much each of the men has in their accounts after 10 years. So what's n in this case? It's 10 for everybody. Okay, at least for part A. So let's see. N is 10. The interest rate for the first case, Andrew, is going to be 4.5. And the PV is going to be 2,000. Now, since it's leaving his wallet, I'll put negative 2,000. And the future value, we don't know yet. We want to know that. C divided by y is the same thing as k, which we know is 1 for this case. So now we just put the cursor on top of FV, and we do alpha solve. So we get 3105.94. So future value is 3105.94. Now we'll look at the case where R is 4.4, which is Billy's case. So we'll just change that. We're going to adjust the interest and the K. So the interest we're going to make lower, and the K we're going to make higher. Instead of K equals 1, it's going to be K equals 2. So if we make the interest rate lower, we're expecting a smaller number. But if we make the K higher, we're going to expect a larger number. We don't know exactly if one is going to compensate for the other. So let's see. Alpha solve. Let's see what we get. We get 3,090.64. So it's a little bit lower than the first one. Now what about Colin? Difference with Colin is his interest rate is slightly lower, 4.3. And then the K, or C divided by Y, is going to be 4. Now we'll go to the FV, and then we do alpha, and then we do enter, and we get 3,067.47. So it's even smaller. Okay, so that's the answer for A. The answer for A was these first values here. Okay, now what about B? How many years would it take for Andrew to have 3,000 euros? So now we'll go back to Andrew's data, which is 4.5% and K equals 1. So we'll put those back in. 4.5, K is 1, and then we want to find the future value. Well, actually, it says how many years would it take for Andrew to get 3,000. So here we're just going to put 3,000 here. And then we're going to go back up to N and say, okay, maybe it's not going to be 10 years, so let's figure out what it is. Alpha. It's 9.2 years. Okay, so it would be about 9.21 years. So B would be 9.21 years. How many years would it take for Colin to double his money? So Colin's case, the interest rate is 4.3, so we're going to change this to 4.3. And we want to know how long it takes to double, so the future value would be double of the present value. Except it'll be positive because we want to know how much comes into his wallet at the end. Then we go up to the N, which is the number of years, and we do alpha solve. And it gives us 16.2 years. So the amount of years to double Colin's money is 16.2 years. And that's it for this section.